Hi guys, I hope you are fine. Guys, let's attempt this question now. This question is on Fourier series, and first of all read it. The question states, a function, and I read it, a function fx is defined by fx is equals to, open the bracket, 1 plus x all over pi, and the limits for that is negative pi and 0. And then 1 minus x all over pi, limits for that is 0 and pi. And then the period for that is 2 pi. That is from negative pi to pi. And the question states, sketch the graph of fx in the interval negative pi and pi. Determine its Fourier series. And so guys, I had prepared some kind of preparation for that, and so I could remove this now so that I can now show what I had prepared. So the first thing guys is that we are going to draw the graph, and we are going to use these two equations. The first one, we are going to use this table. So I come and fix my negative pi on this pi. So on this x, so it's going to be negative pi over pi. That gives us negative 1. So 1 minus 1, this one gives us 0. So when x is negative pi, fx will be 0. Then when x is 0, that will be 0. And then it's going to be 1. So it's going to be 1 plus 0, which is 1. So I draw that for negative pi, between negative pi and 0. So when I come to negative pi, I will have 0 for fx. For 0, I'll have 1. So let's say that 1 is this. At this point, we call it 1. So that is my 2 points. And since it's a linear graph, I can draw it as a straight line between those 2 points. And this is how it comes out now. That is my line. Coming now to from 0 to pi, I can use this side of the table on this side. So I can say 0 there. So if I put 0 here, the whole of this is going to be 0. So 1 minus 0 is 1. I come to pi. So if I put pi there, this is going now to be 1. So 1 minus 1 is 0. I draw that diagram, that line on this. So 0 and 1 is at that point. Pi and 0 at that point. So therefore guys, on this other side, my graph is going to be like that. My line going to be like that. And so therefore guys, we expect this line to move like that on that side, and on this side like that. So guys, what we now do is that we describe that, and this is what we call an even function. Why? Because this is a reflection of this. If you put a mirror in between here, you'll find that line being this line being a reflection of that. And so guys, this becomes now an even function of Fourier series. So I can write here even function of Fourier series. And guys, the equation for this is given as shown. So guys, here are the equations for that. The first one is the series. This is the series for the even function. And in this series, we have a0, which is now defined by that. That is from negative pi to pi. From negative pi to pi, it's given by that. But now if you calculate from 0 to pi, you'd have to multiply by 2. And this is better because you don't have to do 2 times. So now guys, we use this equation. I'm going to use that equation. And for an, you have this 1 over pi and that integral of that from negative pi to pi, of which we prefer now to use also this one. So we use these two equations, guys, so that we don't have to repeat ourselves. So let's go, guys. So a subscript 0 is equals now, I use this equation 2 all over pi 0 to pi. This one fx, our fx, guys, we can use this so that this is, we use this side so that when we integrate from here to here, we multiply by 2 as we have already seen. So that is 1 minus x all over pi, 1 minus x all over pi. That's what we are doing, and therefore we have to sort of, this one you have, here we have 2 all over pi there. I forgot that one. And so guys, we are dealing with this one first. This is dx. So when you do that one, we shall get 2 all over pi. Then you shall have that. Integrate that, you get x. This one you get minus x squared all over 2 pi. From now 0 to pi. So we replace now our pi then with our x with pi. 2 all over pi. So this one for x we have pi minus pi squared all over 2 pi. Like that. For 0, we are going to have something like this. Minus, it's going to be 0 minus 0. So this one we can do away with that. So it's actually 0 alone. So that one we are going to have just 0. And so guys, we can now come and say this is going to be, this is actually it's okay, 0 minus 0, which gives us 0. So this one we can factor out the pi. We have 2 pi all over pi. We are left with 1 minus pi all over 2 pi, of which this pi can cancel with that one. This can cancel with that one. So we are left with 2. And inside here we have half. And so guys, our A0 should give us 1. So that is our solution, guys, for A0. So now coming now to AN, now come to AN like that. So for our AN we have 2 all over pi, integral from 0 to pi, fx cos nx dx. So this one is given by an be equal to 2 all over pi, integral from 0 to pi, fx is going to be 1 minus x all over pi, and then we put cos nx dx. Guys, I believe we are familiar with that. And let me tell you why. So guys, here is the reason why I'm telling you. Remember that we had this question on our last video, and the question was on integration by parts for Fourier series question 2. So this is what, guys, I did. as you can see, this is still the same thing. You can compare that and that. And so guys, we did this question, and to save time, guys, just refer to our last video on that, integration bypass for Fourier series question 2. This is how we did it. And so guys, allow me not to go back to it, but just you can just observe and remember what happened. This is what we did until guys we came to this point whereby we found our AN is supposed to be this. This is our AN now. This is AN. So our AN is supposed to be this equation here. And so guys, we continue with this and we continue up to the end now. So guys, having this equation, we know that N is supposed to be 1, 2 is a natural number like that until we go to infinity. So guys, we now come and say when N is even number, that is to say, we look at this point. We leave this one first, we look at this. This is going to be cos. For example, we can have cos 2 pi. We can have cos 4 pi and cos 6 pi, but let's check for that, guys. So with this one, we'll find that cos 2 pi, which is cos 60, gives us this solution, cos 360. So we say cos 360 equals to 1. We go to cos, that is now 720, 4 pi is 720, cos 720 gives us the same as 1. So all the even numbers will produce 1 as the solution for cos for that number. And so therefore for that, AN is going to be equal to, you can see if this is 1, it will be 1 minus 1, which is 0. So AN is going to be 0 for all the even numbers. Let's now go to now odd numbers. When we say when N is odd number, we have like cos pi, you can have cos 3 pi, you can also have cos 5 pi. So let's use cos 5 pi and cos 3 pi and we see what we get. For cos 3 pi, that is 180 times 3. 180 times 3, that is 3 pi, 540. So cos 540 is equals to -1. So cos 540 -1. For 5 pi, which is 180 times 5 equals to 900. Let's see cos 900. 900 equals to -1. And so therefore, guys, all the odd numbers will give us -1. And so therefore, guys, AN is going to be equal to 2 all over pi squared n squared. This is now going to be 1 minus -1, which now translates to 2. So here we have 2. And so finally, this one is going to be 4 all over pi squared n squared, where n is an odd number. And so therefore, guys, using our equations then. And so now guys, this is our series equation. And we have found that a0 is 1 and now an is 4 over pi squared n squared, where n is an odd number. And so therefore guys, we are going to have fx will now be equal to a0, which is 1 all over 2 now, plus, now we fix this one here. This one will now be 4 all over, we start with 1, so we have 1 squared pi squared cos x, cos n is 1, plus, we again go to 4 all over, now this is 3 squared pi squared cos 3x, like that, plus 5, still it's 4, because 4 is a constant, 4 will not change, but here we have 5 squared pi squared cos 5x, and so on like that. And so therefore, to simplify that, you'll have fx equal to a half, plus you can factor out 4 and pi squared. Then you'll be left with the cos x plus cos 3x all over 3 squared plus cos 5x all over 5 squared plus cos 7x, all the odd numbers, all over 7 squared, and so on guys. That is plus, like that. So guys, this is our series. Thank you for listening to me. Bye bye.